So if, whoops, if I have integers a, b, d, m, and n that are all integers, then d divides a implies that d divides ma plus n times d. I barely got that in. Okay, so let's think of the proof of this. So proof. We know by assumption there is an integer q so that a is equal to d times q. That's just the definition of what it means to be divisible. So m times a plus n times d is equal to, well, let's see, we have m times d times q plus n times d. Okay, now I'm going to do this very, very carefully on the steps here, and I'll say out the steps. I don't have room to write them down. But by associative property, I can write that as m times d times q plus d times n. By the commutative property used twice, I get d times m times q plus d times n. By associative again, we have d times m times q plus d times n. And then by the distributive property, I can factor the d out. There's m times q plus n. Now by the closure property, we know that m times q is an integer, and therefore m times q plus n is an integer. And that's by the closure properties of multiplication and then division. And so we conclude that d has to be a factor of ma plus n times d because the thing in parentheses is an integer. So that's the end of the proof. Now for test purposes, I might ask you to list out every step. If I don't ask you to list out every step, then it would be simply fine to just simply factor the d out and go directly from here to here, and then note that the thing in parentheses has to be an integer.